In this tutorial, we will see about constructors and constructor overloading. So, what is a constructor? A constructor is a special member method of a class used to initialize an object immediately upon creation. It has the same name as the class in which it resides and is syntactically similar to a method. Once defined, the constructor is automatically called immediately after the object is created before the new operator completes. So what is the need for constructors? Normally in a class program that was seen so far, a set method was used to initialize the values for the attributes of the class. But it can be tedious to initialize all of the variables in a class by a method each time an instance is created. Now let's see an example for this. So I'm going to open the command prompt. And now I'll be creating a folder mkdir java programs prog. So all the Java programs I create will be saved in this folder. Now I will open a notepad in order to type my program. So sorry. Yes. So I will write a normal Java program where the class is box. It has three attributes with the data type double. So they are the width, height, and depth. Width, height, and the depth. So normally, in order to initialize the values for these attributes, a set method would be used, as in to set the dimensions of the box. So these are the formal parameters that are being passed to this function. The depth. So when you pass a value, it will be assigned to the attributes. Now this class can be used to find the volume of the box. So I'll write another method to find the volume of the box. So the system dot out dot println function is used to display the output. So now I'll create another class. In this class, I will be defining the main function public static void main string args, and inside the main function I'll be declaring objects for the class box. So I declare the object as box b1 is equal to new box. That's how you declare an object. So I'll be declaring another object box b2 is equal to new box. Now once the objects are created, so here the objects will be created. In order to assign the values for the attributes for each object, you need to call the setDim function. So v1 dot setDim of, let's say I pass 10, 20 and 15, and in order to display the volume, I need to call the volume method. Similarly, for the second object, I call the setDim function in order to assign the values for the attributes. Okay, so this should work. And I compile the program java c space box1.java. Yes, there are no errors. Java box. Java box 1. Okay, so here in this program we have seen that once the object is created in this statement, the initial value for the attributes has to be set every time an object is created. This can be tedious. So here comes the role of constructors. So the need for constructors. Instead of creating, as we saw in the previous example, a set method in order to initialize all the variables for every object creation, it would be simple and more concise to have all the setup done at the time the object is first created. Since the requirement for initialization is so common, Java allows objects to initialize themselves when they are created. This automatic initialization is performed through the use of a constructor. It is the constructor's job to initialize the internal state of an object so that the code creating an instance will have a fully initialized usable object immediately. So Return type of constructors. Constructors have no return type, not even void. We saw that constructor is a method, but a method usually has a return type, but it's not so in the case of a constructor. This is because the implicit return type of a class constructor is the class type itself. So now let's see a constructor program. I'm going to modify the same program. So here in place of this setDim function, I'm going to include a constructor. So you define a constructor first by, it doesn't have a return type, so it's just the name of the constructor is the class name itself. So I'm going to initialize the attributes as width is equal to 10, is equal to 10, and depth is equal to 10. So in this constructor, the attributes have been each initialized as width, height, and depth as 10. So when an object will be created, the constructor will be invoked automatically, and the attributes will be set as 10 each. So here I have created two objects, B1, B2, and once the objects are created, the constructor will be invoked automatically and the attributes will be initialized with the values. And so now I can directly call the volume function in order to display the volume. So I'll save the program. I will compile it right now. So that's one error. Invalid method declaration, return type required. Sorry, the name of the class is box. So save the program. Yes, there are no errors, so I'll compile it. Oops, one. Yes, so we've seen here that the volume of the box is 1000 for both the objects. This is because once any number of time an object is created, the attributes for the corresponding object will be initialized with the same value. So in order to go for a variation to the values that is initialized to the attributes, we can see the different types of constructors. There's a small note. Box B is equal to new box, which is the declaration statement of an object. Here the object will be first declared, allocated, and then initialized. So there's kind of a confusion why they include a parenthesis after the second time the class name is mentioned. So this parenthesis is given after the class name here as the constructor for the class is being invoked. So this is the class name box, B is the object, and the new box, this part is actually invoking the constructor box of that function once the object is created. So in the programs that we have seen so far, there were some programs wherein no constructor was defined explicitly. So how did the attributes for that object get initialized? Here comes default constructor. When a constructor for a class is not defined explicitly, then Java creates a default constructor for the class. The default constructor automatically initializes all instance variables to 0. Once a constructor is defined explicitly, the default constructor is no longer used. Now let's see the type of constructors. So there are two types. One, constructor without parameter, and second one is constructor with parameter or the parameterized constructor. Constructor without parameter, here a default value is assigned to the attributes for all the objects. So we saw an example just now wherein the attributes of the box class, all the attributes were assigned by default to 10. So any number of time you create an object, the same values will be assigned. There won't be any change in it. If you need to bring some kind of a variation in the values that are assigned to the attributes every time an object is created, we go with the constructor with parameter or the parameterized constructor. In order to vary the value assigned to the attributes, parameterized constructor is used. So, different objects have different values to the attributes. So now let's see an example of parameterized constructor. I'm going to modify the same program. So here, instead of not giving any arguments, I'm going to pass some arguments to the constructor. So double W for the width, double H for the height, and double D for the depth. So here, instead of assigning D for the depth. So here, instead of assigning a constant value, I assign the value of the corresponding formal parameters. So that would be W, H, and D. So this is a parameterized constructor. So in this class, the object for the class box is created, and here, as I mentioned earlier, this box of is actually the invocation of the constructor. So here we are using a parameterized constructor, so you need to pass arguments to the constructor. So I will pass as 10, 20, and 30. And for another, I can maybe pass it as 2, 3, and 4. So I will save the program. Oops. Cannot find some. Oh, sorry. Double save it and compile the program. No errors. So I run it. So here you can see that every time an object is created, as in B1 and B2, they are different objects. Different values for the attributes can be passed so that there can be some variation in the objects that are being created. So this is an example of parameterized constructor. Now let's see what we can do in case the formal parameters as well as the attributes have the same name. So in this example that we saw just now, the formal parameters, which are W, H, D, and the attributes, which are the width, height, and depth, are of different names. So there wouldn't be any ambiguity in this assignment statements. But what if in maybe some users, in order to maintain clarity, they might even give the same name as in width, height, and depth for the formal parameters also. So when you initialize there might be there will be an ambiguity created when this program executes. So now let's see what happens. I will save the program. Java, it's executing. So actually here the parameterized constructor is not being invoked. This is because in this statement it is not clear what is being assigned to what. So in such scenarios we will use a keyword called this, which actually references the current object which is being invoked. So this should solve the problem. So here, so if the name of the parameter to the constructor, which is the formal parameter, and the attributes are the same, then the local variable formal parameter hides the instance variable. This is called instance variable hiding. We know that normally in a given scope you cannot have two variables of the same name. So, but here when you tried having, this is the same case, when you tried having the same name for the formal parameters and the attributes, there was an ambiguity created. So to resolve this namespace collision between the local variable and the instance variable, this keyword is used which references the current object, that is, the object on which the constructor was invoked. If this keyword is not used, then all the attributes are initialized to 0 on the constructor invocation. So that's what you saw, wherein all the attributes were initialized to 0. So that is why you got the answer as 0 and 0 here. So when this keyword was not specified, the volume of the box in both the cases was 0 because the width, height and depth were initialized to 0. After you use this keyword, they were initialized to the corresponding values and you have got the volume of the box calculated. So garbage collection. We have seen so far how objects were created and how the memory was allocated to them once it is created. So in case of object destruction, that is in Java, the objects are destroyed and memory is deallocated for later reallocation automatically by a technique called as garbage collection. When no reference to an object exists, then the object is assumed to be no longer needed and the memory occupied by the object can be reclaimed. There is no explicit need to destroy objects as in C or C++ using the delete operator. It will not occur because one or more objects exist that are no longer used. So in case of Java, an object will need to perform some action when it is destroyed. For example, if an object is holding some non-Java resources such as a file handle, then the resources have to be freed before the object is destroyed. To handle such situations, Java provides a mechanism called finalization to define specific actions that will occur when an object is just about to be reclaimed by the garbage collector. To add a finalizer to a class, the finalize method is defined, which is invoked whenever an object of the class is about to be destroyed. Inside the finalize method, the actions that must be performed before an object is destroyed is defined. The garbage collector runs periodically, checking for objects that are no longer referenced by any running state or indirectly through other referenced objects. So the finalize method has this general form. protected, which is the return type. I'm sorry, that's the specifier. Void is the return type, and finalize. And you give the finalization code here. So here you need to perform whatever action that is required once before an object is going to be destroyed. So here the protected specifier prevents the access to the finalize method by the code that is defined outside its class. So the finalize method is only called just prior to garbage collection. So the finalize method may or may not be executed. Therefore, the program should provide other means of releasing system resources and not rely entirely on the finalize method. The static keyword cannot be used for constructor, as for static methods, the class name is used to call the function. About constructor overloading. Constructor overloading contains more than one constructor with different arguments. This plays an important role when you need to perform different operations but for the same kind of attributes. For example, in the example program that we have seen, that is to find the volume of a box, uh, the attributes might change. For example, if all the attributes have an equal value, then it becomes a square and you need to calculate the volume of the square. And if some of the attributes, that is the width, depth and height changes, then it becomes a cuboid. I'm sorry, that was a cube. If all the attributes had same values, then it becomes a cube. You need to calculate the volume of the cube, and if all the attributes are kind of different, then it becomes a cuboid and you need to calculate the volume of the cuboid. So now let's see the example. So here this can be used as a constructor in order to initialize the values for a say cuboid, and I'm going to initialize another one, I'm sorry, for a cube. So as we all know, cube has all the parameters, I mean dimensions for the same value. So just len would be one value and width is equal to height is equal to depth, which will be assigned to len. So if all the attributes are different, then this constructor gets invoked, it becomes a cuboid. But if only one attribute is passed, then it is understood that it is a cube and all the attributes are initialized to the same value and the volume of the cube gets calculated. So in this, when an object is created, here we pass different values, and for the next object we will pass just one value indicating that it's a cube. So I will compile the program, no errors, and I'll run it. Yes, so here the first, for the volume first object, the first constructor has been invoked, and for the second object the second constructor has been invoked. So this is how constructor overloading works. In constructor overloading, just like a normal method overloading, you vary the number of arguments or even maybe the type of arguments in order to invoke the different constructors. So in this tutorial I'll just summarize. So first we saw what is a constructor. It is actually a special member method which is used to initialize an object immediately on creation. It has the same name as the class and it does not have any return type. The need for constructors will be that instead of creating a special function in order to initialize the objects and invoking it each time an object is created, you can define the constructor for the object so that it will be invoked automatically once an object is created. So the return type of constructors, for a constructor, even though it's a method, it does not have any return type, not even void, because the implicit return type of a class constructor is the class type itself. The next would be default constructor. So in case there's no constructor defined explicitly, then the Java will create a default constructor of its own, and here all the attributes will be initialized to 0. There are two types of constructors, with and without parameter. Without parameter is just the normal constructor. With parameter is the parameterized constructor. So in case the parameterized constructors formal variables and the local variables are having the same name, then it causes a namespace collision called as the instant variable hiding. In order to resolve this, you use a keyword called this keyword, which references the current object. If this keyword is not used, then all the attributes will be initialized to 0. Garbage collection is actually used when an object is destroyed. The memory will be deallocated, and this can be used later for reallocation in case another object is created. In Java, the finalize method is used for garbage collection. So, and finally, the constructor overloading. Constructor overloading is nothing but you vary the number of arguments for the constructor so that the different constructors are invoked in case the type of arguments changes. So, thank you. I hope you enjoyed the tutorial and it was useful for you.